Hello and welcome to integration methods. In the end, you're going to learn about why we choose certain methods over others when we integrate functions and how they work. Now, the next integration method we're going to be looking at is integration by parts. Here's how it works. Integration by parts. When is it used? Well, it's used when we have a product of functions. Let's say we have f of x times g of x. Let's say we differentiate this function here, okay? Or product of functions. Well, by the product rule, we would get f prime of x, g of x, plus g prime of x, f of x. Now, let's say we want to take the integral on both sides, or the antiderivative. So, the antiderivative of this, or the integral of this, would just be f of x times g of x. Why? Well, because this expression represents the derivative. This is the derivative. And so if we take the antiderivative, we return to the original function. Or if we take the integral, we return to the original function that we were differentiating originally. If we take the integral on this side, get f prime of x g of x plus the integral of g prime of x f of x. Now we can solve for any one of these. More on that in a bit, but let's say we want to solve for this one, okay? So let's solve for it. That means subtracting this from both sides, so this goes away. And we'd have f of x times g of x minus f prime of x g of x is equal to the integral of g of x f of x. And so we have this expression, which we're going to use and see how integration by parts works. So here we have our equation again. Now let's consider the integral of x e to the x dx. Use substitution. Would that work? No. We don't have a function and its derivative in the integrand, and we don't necessarily have a composite function here. What we do have is a product of functions. And that's what integration by parts is for, when we have a product of functions. Okay, so let's use the equation above. So we have here, okay? There are two ways to use the equation. Now the first way is by saying that our problem here matches this. That means we would let g prime of x be x and f of x be e to the x. Okay, how do we use this formula? Well, we would say, now let's start by doing this. So we said g prime of x is equal to x and f of x is equal to e to the x. Now, to use this formula, well, we need our f of x, we need the g of x, and we also need f prime of x. So let's find those. This implies that df, derivative of f with respect to x, is equal to e to the x. Again, as we've been doing with integrals, the differentials are always written like this, like the df and dx. Oh, I forgot to write dx on either side, so don't forget this dx. If g prime of x is equal to x, and we want to find the original function, we would have to integrate. When we integrate the derivative, we get the original function. So this means that if we integrate, so we have g prime, which this can be rewritten as dg is equal to x dx. Let me bring this down here. So dg is equal to x dx. If we integrate both sides, we would get g. So we integrate this side. This would just be g. This would just be g, which is equal to integral of x dx. And by the power rule, it's x squared over 2. So we've found all the things we need to solve this. We know g prime of x is x, f of x is equal to e to the x, and we found g of x, the original function here, which is x squared over 2, and the derivative f prime of x is equal to e to the x. Great. Now, why didn't I add a plus c here when I did the integral of this function? Well, it's because in the end, all these constants will combine, and we're going to get one single constant at the end of solving our integral. So we can apply this formula. This means that, okay, so we said that this is equivalent to this integral here. This integral down here is equivalent to this, which means we could write the right-hand side as well. Now we can write the right-hand side. Okay, so in the right-hand side, we have f of x times g of x. Our f of x is e to the x. Our g of x is x squared over 2 times x squared over 2 minus, then we have the integral. The integral of f prime of x times g of x dx, and we know f prime of x is e to the x. G of x dx would be x squared over 2 dx. But now we made the process even more complicated. Why is that? Well, we have this integral here of this function here is again a product, and it's even more complicated. We have a power here squared, and so there's a point I have to make here, which is that you have to be careful when choosing. So our original integral was this. You have to be careful when choosing which you want to be g prime of x and which you want to be f of x. More specifically, what I mean is that if we let g prime of x is equal to x, so when we did that, we had to integrate it to find the original function, which was pretty complicated. We now have a power here and this constant here. It's kind of a lot to deal with when we can go for a simpler method, right? So if we said instead that f of x was equal to x, then we would have the derivative of this, and it would just be 1. And if we said g prime of x was instead e to the x, then the original function after integrating would be e to the x. And then using our general expression we have above here, the right-hand side of the general expression, we have f of x times g of x. Let's do that. F of x times g of x minus integral of f prime of x g of x dx. We have all our information here to plug in. F of x is x, g of x is e to the x minus the integral of f prime of x is just 1 times g of x is just e to the x dx. And what we have here is just the integral of e to the x. This is just multiplied by 1, doesn't really matter. It's just e to the x. And so we would have minus e to the x. The integral of e to the x is e to the x plus c. We found our integral using a method that's way faster. So what functions would yield a simpler derivative and what function would yield a simpler integral? So in our case, when we let g prime of x be e to the x, then when we integrate this, we would get a simple, so this would be g of x, because derivative gives us original function after integrating, we would get a simple expression, which is just e to the x again. And if we take f of x is equal to x, we found that the derivative was just 1. Really simple. But if we use the method we started with, we would get, so we said in the beginning that we let g prime of x be equal to x, so that when we integrate it to get the original function, just g of x, we would get this power. And then we ended up with our whole expression minus the integral of x squared over 2 times e to the x, which is again a whole different process of integration by parts that we need to apply again, and that would just result that would just give us more complications and then make the process longer. You have to be very careful in the original integral with what you choose to be what, essentially. And a general rule is that sort of written as like this: I late, which means we start with inverse trig functions, and then we go for logarithmic expressions, and then algebraic expressions like x squared, and then trig identities or trig functions, trig in general, and then you go for exponential functions like e to the x. What this is saying is that this is referring to what we let be a function like f of x, not the derivative what we let be the function. So for instance, in our expression here, we have exponential and algebraic. And what these rules are telling us to do is, okay, which function in this product of functions in our integrand here should we let be f of x or g of x? Well, in our list here, we have algebraic comes before exponentials. So that means that we should let f of x be equal to x, the algebraic expression, because it comes first. So that when we differentiate it, f prime of x would be just 1. And then we could let g prime of x be equal to e to the x, so that when we integrate it, we get e to the x, which is simple. And I want to repeat. I know I'm repeating here, but if we didn't do that way, and if we said f prime of x is equal to x, then we had to integrate this. We had to integrate this, and we would get the original function to be equal to x squared over 2, which is complicated. We don't want this power again, and I showed you the consequence. This is a general rule to follow. It's quite helpful. Just overall, be careful with what you pick to be what. Just remember, if I differentiate this, would it be simpler or more complicated? If I integrate it, would it be simpler or more complicated?